this one says find a fourth degree polynomial with real coefficients that has those 3 zeros. Okay, in order to get a fourth degree polynomial, we'll have to have 4 zeros, because each zero we'll use to get a corresponding factor of the polynomial. Like if 1 is a 0, x minus 1 is a factor. Or if -3 is a 0, x minus -3 or x plus 3 will be a factor, And so if you multiply those factors, you have to have 4 factors multiplied in order to get a fourth degree polynomial. And so just know, there should be a comma here. So just know if the polynomial has real coefficients, then if you have an imaginary root or imaginary 0, then the conjugate has to be a 0 also. There's some theorem that says that. So we know, even though they only listed these 3, we know that since 2i is a root, -2i has to be a root also. So really we have 4 roots that we'll deal with. Okay, so now this polynomial, okay, since 1 is a 0, means x minus 1 is a root. Since -3 is a 0, that means x plus 3, or is a factor. X minus 1 is a factor, x plus 3 is a factor. And then x minus 2i will be a factor, and x plus 2i will be a factor. Okay, and then now we just kind of FOIL all this out. Okay, best way to do this is if you have a complex number and its conjugate, I would FOIL these first. We could maybe FOIL these and then these in the same step. So let's do that. So we'll FOIL these first. So when these two get FOILed, x squared plus 3x minus x minus 3. Okay. And then now when we FOIL these, and we'll simplify this in the next step. And then we FOIL these. So the nice thing about FOILing the factors that come from the imaginary roots is this is difference of two squares. So you can, when you're multiplying the two binomials, and it's the difference of two squares where it's the same factor but one's plus and one's minus, then the easy way is just to do the first thing squared and then do minus and then do the second thing squared. So 2i squared, like that whole thing squared like that. Alright, and then we'll kind of simplify this before we'll do one more FOILing, but let's simplify it first. Okay, 3x minus x, we can combine those like terms. And then x squared. Okay, so when we square 2i, we'll square 2, and that'll be 4. And then remember, if you square I squared, so here I'll write off to the side. So remember, I squared is really -1. And so, yeah, since when we square this I squared, we'll get a -1. It'll cancel out with this negative to become a positive, like that. Okay, and that's why we multiply these, because once we do, we get rid of the imaginary numbers, and it becomes a nice, simple little binomial. Alright, now we just have to FOIL these, or kind of distribute, I guess. Okay, so we'll just do x squared times each of these, then we'll do 2x times each of these, and then we'll do negative 3 times each of these. Okay, so x squared times x squared, x to the fourth, x squared times 4, 4x squared, 2x times x squared, 2x cubed, 2x times 4, 8x, negative 3 times x squared, 3x squared, and negative 3 times 4 is negative 12. Okay, so now we'll kind of put it in order and combine any like terms. Yeah, okay. So, and I'll cross out terms as we use them. So x to the fourth, and then we have just that one cubed term, 2x cubed. That. Is that right? We only had one cubed term? Yeah, okay. And then we have the two squared terms. So 4x squared and negative 3x squared is just positive x squared. And then we just have those last two. So, whoops, plus 8x minus 12. Okay, so we have this fourth degree polynomial, and it'll end up having those roots that they wanted it to.